Welcome back with another exciting video. In this video, we'll build a scalable URL shortener. Functional requirements. We'll fulfill two functional requirements. Given a long URL, generate a short URL. Given a short URL, redirect to a long URL. Non-functional requirements. Even here, we'll fulfill two non-functional requirements. Low latency, high availability. Capacity estimation. So assume there are 100 million daily active users. If each writes one URL per day, then there are 100 million writes per day. If read to write ratio is 10:1, then there are 1 billion reads per day. So the writes per second becomes almost 1160 requests. The reads per second becomes almost 11,600 requests. So what characters can we use in our URL shortener? Shorten ID. If there are 100 million writes per day, then 100 into 365 is 36.5 billion URLs created each year. So if we use base 62, so 6 power 62 is 56 billion. So it will almost create for 2 years, which is not enough. So we'll consider 7 characters in our shorten ID. So 7 power 62 is 3 trillion. So which is much enough. Database design. For our URL database, we will use NoSQL because we require no joins, and also NoSQL is scalable and highly available. For storing short ID, we'll use SQL because if two concurrent users goes queries at the same time to generate the short ID, then there is a chance of both getting the same ID. So what we do is we take separate SQL database, we store all the short IDs generated by the short ID server in that SQL, and we will see whether that particular short ID is already used or not. So short ID database contains short ID and is used. If it is not used, we can use the short URL. API design. We will consider two APIs. Shorten URL, which takes the long URL and returns a short URL. Redirect URL, which takes the short URL and redirects to a long URL. Now let us design a high-level design for this URL shortener. Let us consider a user. Shorten URL service. When the user provides the long URL to the shorten URL, then the shorten URL as the short URL server to generate the short URL. The short URL generates the short URL and checks in the SQL database which stores the short URL and the is used or not. SQL database. It checks in the SQL database. If it is not used, then the generate short URL says the shorten URL, gives the shorten URL with a shorten ID, and the short URL stores it in the NoSQL database. NoSQL database. URL DB. URL debug. The other service is a direct service. When you give short URL to the redirect service, it checks in the database and redirects to the particular long URL. This satisfies all the functional requirements. Coming to non-functional requirements, low latency. As there are 10 almost as the read to write ratio is 10:1. So for every read request, the request goes to the database and the database might crash. So what we will do is we'll use a Redis cache. So frequently accessed URLs are getting stored in this Redis cache. First, the redirect URL checks whether the particular URL is present in the Redis cache or not. If it's present, it's cache. If it's not present, then it checks in the database, which satisfies the low latency non-functional requirements. For high availability, what we do is when this shorten URL service fails, we will duplicate the shorten URL service. So if one fails, the other service runs. The same way the redirect service, if one fails, the other runs. The same way the generate URL service, if one fails, other runs. We will add load balancers for this. We'll add load balancers for these services. And also for the database, if one database fails, then the system crashes. So what we'll do is we'll replicate the database. Yes, this is our URL shortener design. If you like this video, please consider like, share and subscribe. Thank you.